This movie describes how to use the compose a locus composition domain and range activity. This is one of the geometric functions activities in which students create, manipulate, and experience function concepts by treating geometric transformations as functions with points as their variables. This activity introduces the locus construction to create the range of a function with a restricted domain. Because the locus is a construction rather than a trace of the range, we can use it in more powerful ways to investigate changes in the domain or changes in the parameters that we've used to define the functions. Students start the activity from a blank sketch, but I've short-circuited several of the constructions. In this activity, we're going to review function composition. We're going to restrict the independent variable to a domain and then construct a locus to investigate the behavior of the range. So we begin by noting that the functions I've already created here include a dilation by a scale factor of 0.8 about center C, and a rotation, also about center C, by angle theta 45 degrees. We compose the two functions by selecting the input to the second function to merge to the output of the first. We perform the merge, and now we have an inappropriate label for the second, for the ultimate dependent variable, because y no longer exists. Y, in fact, is now the dilated image. So I copy that label and use that in place of the y here, paste. So now the dependent variable is the rotation about c by theta of the dilation about c by scale factor s of x. And we can also hide the intermediate variable. We don't really need to see that anymore, because even without that variable, we now see the composed function with no need to see the intermediate steps. Okay, so we have our function, and now we're going to restrict it to a domain. So I'll show a polygon that I already created, and select the polygon and the independent variable, merge the point to the polygon, and now we get to see, by tracing these two variables, what happens if we drag x around the polygon, and rather than dragging x, we're going to actually create an action button, an animation action button, which will automatically move variable x around its restricted domain, and we get to see how the range changes, how the dependent variable changes as x moves. Now say we wanted to change the scale factor from 0.8 to 0.5. We can do that, and because we're animating, we still get the result. But we're now seeing both sets of traces for the range. Similarly, if I change the angle here to 90 degrees, now we see yet another example of the range. And we could just erase the traces, and then the new traces will show only the current state of these particular functions. But there's a better way, and we're going to use that better way right now. For the better way, we will erase the current traces, turn tracing off for our two variables, and instead of using traces, we will use the locus construction with point x and the dependent variable selected. We'll construct the locus, which is the locus of the dependent variable, showing where it moves as x moves around the restricted domain. So that locus is actually the range. And let's watch this point animating. As x animates around the domain, the dependent variable moves around the range, so the locus really does show us the range. Okay, so one will ask students a number of questions as they go through this activity. Draw what you see. What does the locus represent? We've just decided that. Create an animation button to animate theta bidirectionally between 0 and 180. Let's try changing theta first without creating a button, and then we'll create the button in a moment. An easy way to change angle theta is to select it, and instead of editing it, just press the minus sign or the plus sign on the keyboard. So I'll press the minus sign, 85, 80, 75, 70, and watch how the range just changes. As we modify theta, I'll try the plus sign now, and we get to see the whole time how the change in the angle affects the range. So this gives us a much more powerful way of investigating a function. Now we're supposed to create an animation button that animates it bidirectionally. We can do that. Select angle theta from the edit menu, make an action button for that to animate from 0 to 180 bidirectionally. So we click the OK button. So now we can animate the angle parameter to avoid confusion. I'll stop the point animation and we can just watch as we change the function, change the rotation function from a 0-degree rotation here to a 90 and eventually a 180 rotation there. So let's review what we've done. We've composed two functions. We've used proper function notation to label them. We've restricted the function's domain. We've constructed the range by using the locus construction. We animated the independent variable over the restricted domain to make sure that the locus construction really matches the corresponding values of the dependent variable. And then we animated the angle measurement to observe a continuously changing mapping, a changing function, different members of the same family, that mapping of the domain to the range. So that's the compose a locus activity.